don't want to take up too much time. The second data set was the adult salary, so 48,000 records, 13 columns, dropped two of them off the bat. There were no nulls, but there were question marks in the data values, so that it might as well just be nulls, and we dropped those. And then we noticed there was leading spaces and trailing periods. So we had to clean that up. And based on the income column, which was going to be the outcome variable, there was only two possibilities, which was greater than equal to 50K or less than 50K. So let's hop into that real quick. Yeah, so we dropped the final weight since it specified that it was intended for a census survey, which is not relevant for us. And then we dropped the education column because there was the education num, which was just the numerical value in an ordinal manner, essentially what we would have wanted to transform the education column to was already done for us. Okay, so here we got all the unique values for all of the non-numeric columns, and this is where we deduce that there's leading spaces in all of the text, and then there's 3 question marks present in the data, which we treated as nulls, and then here we see that there's less than equal to 50, less than equal to 50, and then trailing periods. All right, so we dropped all those question marks, aka nulls, and then we removed all the leading spaces, and then we moved the trailing periods from the income column. With both the same unique values, so we can see it looks a lot cleaner. Then we're left with only 2 values for the income. Normally we had, what was it, 48? Yep, 48, and after that cleaning process, we're left with 45,000, which is still plenty of observations that we could use. None of these graphs really stood out too much. There was a lot of outliers, but we'll see how much that affects the final model. Not a lot of correlation on the scatter charts that you can see. Positive correlation, no, just, I don't know. It's hard to interpret. So all of the categorical columns had we had to create dummy variables, and that resulted in roughly 80 different columns, which we fit into our model. So we know income was the outcome variable, and then everything else was set as a predictor. Then we did the split by the scalar. With the logistic regression, our accuracy for that was 85%. And the crossflow validation was essentially 85. So it seems like a model performed well enough. The logistic regression in capturing that adult salary if it's greater than or less than 50K. For the third model, we were building using the car evaluation data set. And see what we're dealing with. 1,728 records, 7 columns, no headers, so we had to assign the headers. Checking for nulls. We noticed that all of the categories had 3 or 4 unique values in ordinal matter. So since they were text, we would have to remap them into a numeric ordinal system so we could feed it into our graph, which we noticed were nonlinear graphs, and that led us to selecting the k-nearest neighbors. So new columns, assign columns, text and some numeric and others. No nulls, 7828 records, all objects right now, 4 unique values, and most of them 4 or 3. All right, so let's see, what are those unique values? Like we said earlier, they follow like an ordinal system. So we mapped them. So 0, 1 to 3, 0, 1 to 3. Um, oh, and then after remapping them, they check out the integers, which is what we need for our model to be able to process that data. Here we can see that I pulled the count of values grouped by the unique, uh, by each unique value in each column. The reason I did this was because these columns were suspicious, but I was able to confirm that there was even distribution amongst all the columns, which meant that there was like a nonlinear relationship between the predictors and the outcome. So that is why we decided to go with the k-nearest neighbors. So here we assign the predictors and the outcome variable, do the training, skip the scalar for this one. This resulted in a 95% accuracy. Um, tenfold accuracy of 97%. So in the end, it seemed like the k-nearest neighbors was the ideal model for that particular data set. Oh, don't know why I did that. Okay, so last part is to evaluate and compare. So the first one we're comparing is linear regression against the decision tree regression. So we can see that in the linear regression, we got a 0.49 R-squared score, and the decision tree regressor um, got a 0.14 in its R-squared score. And when we look at the tenfold cross validation, the linear regression performed on average a little bit better than the initial, and then the decision tree performed a little bit worse on average than it did initially. But let's jump into it real quick. This one. All right, so I just took the part 3 and added a decision tree section to it at the very end. So initially, when I created 2 new records for the linear regression model, which was going to predict the number of rings for the abalone, um, it predicted that the first record would be roughly 10, and the second record would have about 12 rings. And when I had the decision tree attempt for that, it gave record 1 14 rings and record 2 12 rings, which seems a bit odd. The second record was close, but the first record seems to be vastly different. So we created 2 new records to see what would happen. This time I made the first record a infant. Um, to anticipate uh, what the outcome would be, so that it seems like I made a mistake here by giving it two sexes, but either way, having this infant value present should drive down the predicted value of the rings, since the average um, number of rings an infant has is relatively smaller than the males and females. And we can see that here when we apply the linear regression model, we do get less rings for the record that was an infant versus the second record that wasn't. However, in the decision tree model, it states that the first record would have 20 rings, which is pretty absurd. I mean, I think that the highest value, the highest value in the range was 29. So it's not like out there, but for a record with smaller or lower values compared to the second record. So it would indicate that that would be a smaller specimen. Not to mention it's an infant. Yeah, it's predicting it would have 20 rings. Seems a bit inaccurate, and so I believe this assessment that the linear regression model performed more effectively than the decision tree model was accurate. On the last one, we compared how the logistic regression would perform against the key nearest neighbors. Key nearest neighbors had a very high accuracy score, both on the initial and even on the tenfold, with very low variance. Whereas the logistic regression model had an 84 and performed even lower on the tenfold cross validation, with very low variance as well, but still overall just it's about a 16% difference. Um, or 0.16 difference between this and that. Oops. So let's see what happened. Okay, so for this one, I believe I took the car evaluation data and we performed the key nearest neighbors, and then I ran a logistic regression at the very end. So here's the key nearest neighbors first prediction of the two new records. And here are the records. So price 0, low maintenance, lots of doors, passengers, luggage, safety. And then the second record, very expensive, a lot of maintenance costs, less features. And the key nearest neighbors gave record 2 a 0, which is the lowest evaluation, but it only gave the initial record a 1. And again, this was on a 0 to, sorry, 0, 1, 2, 3. Yes, so 0, 1, 2, 3 scale. So would have expected the first record to perform a little bit better. Um, when we introduced the logistic regression, this was the predictions for those same records, which seems to be a little bit better or more aligned with what my expectations. However, we created a second set of data. So here it is, the first record, low price, near nothing, or very low maintenance costs, pretty lower end on the amenities, not very safe. And then second record, a little bit pricier, a little bit more maintenance costs, better amenities, more safe, and for luggage. And these were predictions. This was a prediction of the K-nearest neighbor. This was a prediction of the logistic regression. And I'm not really sure. I mean, I guess they were very close. I wonder what the logistic regression weighed more on to give this one record 2 a 1, and then what the K-nearest neighbors gave value, what feature had the most value to for them to give this a 0. But yeah, there doesn't seem to be the one size fits all model. Certain data works better with certain models. But yeah, thank you for sitting through my presentation. Please check the Word doc for the utility. Thank you.